Okay, we continue this one. Okay, uh, okay, we map the value. It will be acceptable. It will be acceptable if x2 also pointed to y1. Okay, in fact, if we have this case, then what it means is that this x2 is actually just x1 in a disguise. Okay, if we have the x2 and then we map to x1 y1, and then we can say in the disguise so that this one also refers to x1. Okay, so that what it means, it is injective. So well proof that an equation is injective, and when we have the equation like this, the f of x is equal to okay. Okay, so instead we can say that fx equal to 3x minus 2 is injective. Okay, injective. Uh, and then as I mentioned before, x1 is not equal to x2, and f1 is not equal to f2. Okay, it is easier to prove that this one is contrapositive lah. Okay, we can say that x1 is not the same of x2, and f1 fx1 is not the same of fx2. Okay, we can say this one is to prove this one is contrapositive lah. Okay, this one is injective lah. Injective, we map at least one element lah. Okay. And then one-to-one function is the function of fx equal to x from the set of integers. The set of integers one-to-one. Okay, we need to prove lah. Okay, we have for all x, for all y, and then x power of 2 is equal to y power of 2. It implies x equal to y. And then 1 power of 2 is not the same, is equal to minus 1 power of 2, but 1 is not equal to negative 1. So that we can conclude that function fx equal to x power of 2 is uh, not one-to-one function. No lah. The answer is no lah, because we can look here, not one-to-one, because we can see here that can be mapped more than once. Negative 3 is 9, negative 2 is 4, negative 1 is 1, 0 is 0, 1 to 1, okay, 2 is 4, and 3 to 9. Okay, not 1 to 1 because okay, we map more than one. Okay, if the function fx equal to x plus 1 is one-to-one function, okay, you need to have the logical okay statement first. Okay, and then we can say x plus 1 is not the same of y plus 1 only when x not equal to y. And then the answer is yes. Okay. For example, here we have x, okay, negative 2 equal, we map to negative 1, and then when we have a negative 1 is equal to 0, okay, and then 0 we have 1, and then 1 we have 2, and so on. This one is one-to-one function, and we can call it this one as injective. Okay, do you have any question so far? Yeah, so another example that we have done. Okay, another example for injective is that fx equal to 3x minus 2 is injective. Okay, we can say that fx 2 and then 3x 1 minus 2. So it's equal to 3x. Okay, we can have 3x1 equal to 3x2, and then we go this one, then we can have x1 equal to x2. So in it is objective one to one. So with that, does look like graphically with it. So it looks something like in the graph. Okay, in the graph we can have the graph like this. Okay, so okay, this one is negative 2. Okay, and then the graph will be like this. Okay, this one 3. Okay, it correspond to this value up when you will be 7. And when we do this, we notice that okay, we have 3 and 7. 7. Okay, and then we notice that if we go that to the left or go to the right, there is no other values that goes to the exact same y. So that no other x can be choose that given us the same y. 3 is the only value that going to give us of function f of x equal to 7. So that is the proof that 3x minus 2 is injective. Okay, so that this one is injective. The answer is yes, because it map one to one. Akif Lokman boleh ke? Muhammad Akif. Boleh. Kalau tak faham tanya. And then we go for the another function, onto function that we call it as a surjective. Surjective is, in other words, is every value in the codomain. Codomain that there is a value in domain that is mapped into it. Okay, we have A mapped into 2, and then we have B mapped to 1, and then we have C mapped to 3, and then D mapped to 2 again. uh, is in other words that for all y for some x fx equal to y lah. And codomain is equal to range lah. Okay, this one subjective Okay, for example, we have subjective. We map into x and y lah. Okay, here we have x, and then we have y lah. And then we have x1, x2, x3, y1, y2, y3. Okay. Okay, and then we have function here. And then we for the subjective we map here. And here we map here. Okay, it means that each of them need to go exactly one in the domain, and because in a function we have to use all the domain, it means that uh, size of x and y, well, all of this is our domain lah. Okay, and then the size of codomain lah. Okay, if we have the x cardinality x equal to y, okay, we have a cardinality x. We can have a bijective partial function, but we can have a bijective function. So it's very good test if we see a function in the first place. Okay, the cardinality should be same. Okay, this one is for injection. Later we see the inverses. Inverses for this one. This one is subjective. Okay, and then onto function is the function of fx equal to x power 2 from the set of integers to set of the integer onto. Onto function is the uh, injective. It's a subjective. Okay, subjective. Okay, for example here, for all y for some x, x power 2 is equal to y. There does not exist a x such that x equal to 1 is negative 1, for example. Okay, and then negative 1 is one of the possible values of y. Okay, this one is the answer is no lah. Because this one more to into function is more on the one to one. Okay, and then is the function fx x plus 1 onto function. The answer is yes. Why? Because this one onto function is not one to one. Okay, and then if we have integers not onto functions. Okay, because we don't have 5 to 8. Okay. Okay, then we have a one-to-one correspondence, or we can call it as a bijective. Bijective. If the function f is the both one-to-one and onto, both one-to-one and onto. Okay, for example, we have seen this one. Both, for example, we have x1, x2, y1, y2 lah. Okay. Okay, for the function f, both one-to-one and onto, both this one. Okay, and then this one-to-one but not onto. This one onto but not one-to-one. Okay, because one-to-one but not onto because two is not included. This one onto but not one-to-one because A and D is mapped into two for the codomain. For the one-to-one correspondent, okay, we have A mapped to 4, B mapped to 1, C mapped to 3, and D mapped to 2. This one-to-one correspondent. Okay, it is one-to-one and onto. Okay, then we have monotonic. Monotonic means that this one is either increasing or decreasing by the range. This one we measure by the range. For example, increasing is fx is less than or equal to fy, and then decreasing by the greater than or equal to. Okay, monotonic function. For example, we have fx equal to x plus 1. Okay, and then increasing by down to up. Okay, this one is increasing. This one also increasing. And then while two both increasing, this one is we call it as a monotonic function. And then this one is fx equal to negative x, okay, plus 1. Okay, this one also increase, this one decrease. Okay, okay, you can have both, either increasing or decreasing. Okay, here we have both increase. Okay, this one we have either or increase and decrease. Okay, for the increase and decrease function, we can show by the fx. Fx 2x plus 1 is increase. Okay, and then negative 3x minus 1 is the graph, is decrease, and then slope. And then fx 2x minus 1 is increase by the slope. For example, here we have fx mx plus c. C is the constant. Okay, and then we have a slope here. The negative is decrease, positive is increase. Okay, based on the slope. Okay. Okay, this one is another example. We have increase and decrease. For example, we have fx negative 3x minus 1. Okay, this one is the decrease. Okay, and then we have fx 2x minus 1. We have negative 1 and 1.5, and then this one, the graph will be like this. Okay, another example, if we have gx 2 and then function gx1 x1, and then we have x1 and x2, and then we map the mapping will be decreased lah. If you map like this, gx1, okay, and then after that is gx2, the function slope will be increasing. It's based on the slope. Okay. Do you have any question? Is it okay? Okay, we I give you another example lah, because this one we have to take note for monotonic functions. Okay, for example, we have two questions. Wait, two questions here to determine either this one is monotonic or not. We have fx equal to question one. Okay, if a function is monotonic, then the function is one to one and therefore has the inverse. Okay. Okay. Later we see inverse function. Okay. We have fx. Okay, and then okay, we have fx. Later we see the inverse function. Okay, this one is just for the recap. Either this one is monotonic or not. To x. Okay, and then here we have here. Okay, for example here we have -4. Okay, and positive. Okay, and then we have this one inverse function. This one is not monotonic lah. Okay, because for the monotonic you must remember it is either increasing or decreasing lah. Okay, it cannot be n. It must be all lah. Okay, either increasing or decreasing. Okay, for this one we have a static. It's not monotonic, and not also one to one. Okay. Okay, and then for this one we have fx equal to 2 plus cosine x. Okay, is greater than 0 lah. Okay, greater if you have the range, then yes, we have this one. We can say this one is monotonic. Okay, and then has one-to-one relationship. Okay, for this one. Okay, for number one and number two lah. Okay, is it okay? Because monotonic you must have the range. Either this one slope increasing or slope decreasing. Okay, this one for the example. Is it okay, Aziz? Okay, and then we have inverse function. Inverse is should be one-to-one correspondence, such that fa equal to b lah. And then the inverse function is denoted by f negative 1b equal to a. Okay, we have inverse. Inverse mean that we reverse the function. Okay, we have f is a function, and then we have inverse function. Inverse is we map from the codomain to the domain. We inverse back. Okay, and then we can denote by f negative 1. Okay, this one is function. Function must be bijective and one-to-one correspondent. Okay, for example, we can have f ABC. Okay, fx x plus a minus by x and mx. For the inverse, you must have a y minus a minus y, and y divided by m. This one is for inverse. Okay, and then f needs to be a bijection. If f is not a bijection, one-to-one correspondent, f is not injective. And then f is also not a surjective onto. Okay, why can invert such a function? Because we cannot assign element in B in codomain and a unique element in domain such as f a equal to b, because sum of the b neither more than one, and not no such a not a surjective. It must be both. Both one to one and on to lah. Okay, and then after that, then we can have the invert. We can do the invert function. Okay, for the inverse function, let f z integers map into integers, be the function of fx equal to x plus 1. Is f invertible? Is f a bijection? Okay, one to one, yes. F on two function also yes. So f is one to one correspondent, and therefore it is invertible. It can be inverse. Okay. Okay, we have f y equal to y minus 1. Okay, this one, okay, we map one to one first. Okay, okay, and then inverse function again. Okay, function with fx equal to x power of 2 is invertible. No lah, is f one to one. No lah, because it can map 2 and negative 2 from codomain to the domain twice lah. So f is not one to one correspondent. So f is not invertible lah. Okay, this one is not fulfill the condition. Okay, example this one. Okay, for this one we look into the outer function and inner function lah. Okay, for the f gx, we replace gx by the fx lah. And then we go by the gx equal to f 3x plus 2. Okay, and then 2 3x plus 2 plus 3, and then 6x plus 4 plus 3 is 6x plus 7. Okay, here we can see the output is not the same. This one 6x plus 11, 6x plus 7. Okay. Okay, composition of inverse. First, we need to identify is this one is invertible or not lah. Okay, another example. Okay, we have fx equal to x power of 2 plus 5, and then we have gx equal to the power of 2x minus 5. And then f gx equal to x, and then we replace it. We replace a g fx equal to x plus 5 minus 5, and then the power of 2. Okay, x power of 2 is equal to x. So fx equal to x power of 2 plus 5, gx equal to x minus 5. Okay, is we replace by y equal to x power of 2 outer, inner loop plus 5. Okay, and then after that we can conclude this one is equal to y lah. Okay. Okay, and then another example, we have fx equal to 3x plus 8, uh, gx equal to 8x power of 2 minus by 3, and then we replace the gx here, and then we have 3x minus 3 plus 8 equal to 24, x power of 2 minus 9 plus 8, and then 24x power of 2 minus 1. And then this one f gx is not the same with the x. So we can conclude that gx is not reversible for fx. The output must be same. Okay, this one for fx. Okay, we have y, and then this one for gx. Okay, it's not the same of reversible fx. Okay, another example is fx equal to 7x plus 5 is equal, and then the other one is gx x minus 5 divided by 7. And then we replace f with the gx. Okay, and then we replace this one with x minus 5 divided by 7. Okay, and then we have equal to x. Okay, okay, and then for gx, okay, we replace by fx, and then we have x, also have x. So in this case, we can say that gx is reversible or invertible with the function fx. Okay, fx is equal to g reversible x, and gx is equal to f reversible x. Okay, you need to prove this one must be same. Okay, another example is y 7x plus 5 x 7y plus 5 lah. And then if we invert this one, we can have x minus 5 divided by 7 is equal to f inversible by x. Same. Same with the gx. So we can say that fx is reversible by g function g, and function gx is reversible by function y, function fx. Okay, sama eh? This one. Nurinilia tadi okey ke? Boleh faham ke? We need to have the proven invertible. Okay, and then this one important function floor. Floor. Please submit to Padlet lah. Padlet. And then we have negative 2.1. Okay. Negative 5.9. Okay. Okay, for the floor. Floor function is x be a real number. The floor function is the closest integer less than or equal to x. For example, we have half. Okay, half is equal to 0. The floor. Okay, 0.5 less than is equal to 0. Okay, and then negative 0.5. Okay, the floor is equal to negative 1. 3.1, the floor is 3, and then 7, the floor is 7. Okay, okay, please do this one in a Padlet. Okay, this one is the floor. If you have the values, okay, we have, for example, we have negative 1.2, okay, and then is equal to negative 1. Okay, for example, we have here negative 1.2 is equal to the floor. Floor is okay less than or equal to the closest value. Okay, and then this one is shilling. Shilling is x be a real number, and then the shilling function is the closest integer greater than or equal to. We get the upper value. For example, 0.5 equal to 1, negative 0.5 equal to 0, 3.1 equal to 4, okay, 7 equal to 7. Okay, please do this one in a Padlet also. Okay, this one is the graph. Okay. Okay, so far do you have any question? Is it okay? Boleh ke? Amma Ashraf boleh ke? Boleh.